Lovely. We're going to discuss a very interesting idea today. We're going to talk about who is Pythagoras and what is the Pythagoras theorem. And so, I'm sure you've all heard one of the most famous theorems in the history of mankind, not just restricted to math, everything. Almost everybody has heard of Pythagoras theorem. We might not know its several applications or its proof or its beauty, but we've all heard of that. We've heard of Pythagoras theorem. And so who is this guy, Pythagoras? Pythagoras was a Greek philosopher. And I must say Greek. And he's a philosopher. He came from a Greek place called Samos, and he settled in, I think, Croton, one of those Greek provinces. He was there in about 500, 600 BC, around about that timeline. What is special about Pythagoras? He was a philosopher more than a mathematician, but he was also a mathematician. So he was several things. So he had a certain belief about how several things came into being, about the world, how it came into being. They had a group. We're going to talk about not so much about his philosophical beliefs, but about the mathematical ideas. And so he came up with this theorem. Again, we don't even know whether he came up with this theorem. The record keeping and the history is a little bit weak because it's so long back ago that we don't know exactly what happened. And it is very well known that they had a group called the Pythagorean Brotherhood, the Brotherhood of Pythagoras. And they had a way of life called Pythagoreanism. And one of those tenets or beliefs in that is they believe heavily in it being a secret brotherhood. They're having their own methods. And several things were signed off as Pythagoras, but we don't know whether it was Pythagoras who did it or someone else and it was passed off as Pythagorean thing. Right? So even that part is incidental. Pythagoras theorem is a beautiful idea. It works, all of us know this. This works specifically for right angle triangles. If you have a right angle triangle, then the angle opposite, the side opposite the 90-degree angle is called the hypotenuse. The sum of the squares of the sides containing the right angle is equal to square of the hypotenuse. That's what Pythagoras theorem is. There's several applications. There's applications when you're building a house, when you're building a bridge, in doing simple math calculations to get 100 out of 100 everywhere. There's several super applications. Right? So the sum of the squares of the sides containing a right angle. So this square plus this square is equal to hypotenuse square. It's a beautiful idea, proved very simply, very elegantly in many ways. There are many proofs. That's the Pythagoras theorem. That's what he gave. But now it came to be named by Pythagoras, but with several civilizations had used this in several of their constructions and civilizational milestones. It was very crystal clear that definitely the Egyptians had used it. There's reasonable evidence that the Chinese had used it, and some evidence that Indians had used it. So before Pythagoras actually propounded it and named it. So one key lesson from here, if you come up with something, better name it quickly. And so Pythagoras theorem Pythagoras was not probably the guy who came up with it. And the Pythagorean group came up with it. They probably were not the first to come up with it, but they had this brilliant idea to come up with it, prove it, and name it. And so the Egyptians definitely came up with it beforehand, because if you went to their structures, the buildings, it kind of betrayed clearly that they knew how to calculate the hypotenuse. They would have right angles, and then they would measure out a rod and keep it there. How would they know how to measure out and keep it there? Because they knew that if this was the height, this was another height, then that distance, this was one length, that was another length, then that distance is clearly known. So they knew that. So they were using it in somehow. And so that's the background on Pythagoras theorem. And so what else do we know about Pythagoras himself? What is the Brotherhood? Their philosophical beliefs, I'm not going to get into them. Their existential, metaphysical, all those things, I'm not going to get into them. What they thought of spirits and spirituality, mystic. There's a heavy intersection of a cult, a group of philosophers, and mathematicians. I'm interested in the mathematical angle. And so a bunch of things, again, the evidence and the historical bookkeeping elements are not clear on this at all. There's no clear data on exactly what they believed in, exactly why they believed that, how it was proven or disproved, none of that. And so it's very hazy. Back then, the record keeping was not so formal, so clear. So it's been passed on from generation to generation. Somewhere, somebody said, hey, let me put this down. But just putting it down came 600 years after Pythagoras lived. So there are gaps. And so several of these stories, we don't know where story begins, where history begins, and where mythology creeps in, where it becomes an anecdote, and one weird mishmash of all of this. Right? But anyway, coming back to the Brotherhood, let's forget the spiritual, cultish things that they had. Mathematical thing. They believed that there was some math and numbers everywhere. They believed that number 1 was special. They believed number 2 was special. They believed 4 was special. They believed there were some perfect numbers. They believed that natural symmetry had something to do with numbers. They believed several things underlying naturally occurring phenomena are mathematical ideas, numbers. They were incredibly fascinated by natural numbers. They were not called natural numbers back then, but they were incredibly fascinated by it. So they proved that there are incredibly or infinitely many, not incredibly many, infinitely many Pythagorean triplets of natural numbers. They proved that. So they were extremely fascinated by this. So one of the tenets, again, this is apocryphal. We don't know if this is actually true. One of the core tenets was that everything in the world is either a natural number or it can be grabbed as a ratio of 2 natural numbers. I'm talking about this room. 4 meters by 5 meters, 4:5, ratio of the dimensions. Or I can say, hey, how many fingers are there? 10 fingers. Everything in the world is either a natural number itself or its essence can be captured as a ratio of 2 natural numbers. Brilliant. So nice, interesting hypothesis. So that was what the Brotherhood was all about. And then what happened? It's a very interesting story. Again, we do not know whether this happened. There was a gentleman who was part of the Brotherhood. I think his name was Hippasus. And then he was fascinated by numbers. He proved several of their hypotheses. He built the theoretical framework which laid the foundations for a lot of mathematical theories. One of the things that he did, he said, look, hey, I understand that 2 square is 4. I understand that 3 square is 9. Therefore, I can inverse it and say, if something square is 4, that something is 2. If something square is 9, that something is 3. And then if I think about it and say, if something square is 2, what is that something? And I think deeper and deeper and deeper. I know that something square is 2. This fundamental something, it cannot be expressed as a ratio of 2 natural numbers. Right? So, effectively he's saying root 2 cannot be expressed in the form p by q. Several of you might have seen proofs of this in our regular textbooks, or you will end up seeing proofs of this here. Prove root 2 is irrational. It's a standard question. It's been passed on from generation to generation. There's this guy who's lived in this entire belief that everything is p by q, natural number by natural number. And then he suddenly realizes, if I define this root 2, it cannot be expressed as p by q, and he went on to prove it. Probably we are all learning a variant of that proof that he came up with, which is a big deal, because it contradicts one of the very tenets of what the Brotherhood believes in, or what we think the Brotherhood believed in. Remember, there are lots of gaps in the story. So don't come back and tell me that this never happened, sir. You told me this. I know there are gaps. We're having not even an academic discussion, a fun discussion on what might have been. So the Brotherhood got to know this, and then they reacted brilliantly. They said, look, hey, this is very nice. So this guy has come up and he's expanded our sense of what it can be. But this comes against a very core thing of what we believe. The story goes that they got together and they killed him. And so a typical leader's way of treating with people who don't agree with them has been around for more than 2,500 years. Once again, it's just a story. It's very possible, very likely that it was not true. But the idea that they held on to their belief, that they had a brotherhood, that they had thought everything was mathematical, that they had an interesting intersection of philosophy and mathematics, philosophy and numbers, is super important. It's not important, it's fascinating. The fact that 2,500 years ago, they gave time and energy to abstract thought and built theories and built reasoning ideas largely for the heck of it is fascinating. So they found time to think out philosophy. Several of the philosophical frameworks laid by the Greek scholars are used to this date. Obviously, the mathematical ideas are again used to this date. The intersection of mathematics and philosophy is where Pythagoras sat. So fascinating. So if you're thinking, several of you students keep asking me, where do we use quadratic equation? Where do we use cubic equation? Where do we use sine cube theta, cos square theta? Where do we use trigonometry in real life? The point is not to find a real tangible use for it today. The point is to have the toolkit to be able to think about abstracts, so that next time an abstract idea comes in and hits you, abstract question hits you, you have the toolkit to go and attack that, because you've done several questions with trigonometry and quadratic equation, right? So the abstract ideas are not for nothing, right? So they're beautiful in and of themselves, not because they can get you to solve on how many people should be made to stand in a row for a school assembly. Everything is not practical, but everything has beautiful use, especially those ideas which build your abstract way of thinking. And so with that, I'm going to sign off. One of the greatest, oldest, most fascinating theorems of all time for all mankind. And the story behind the person who did it, or the people who did it, with several gaps. There's more gaps than you can imagine. Most of this is reconstructed from several anecdotes which have been passed on generationally and then compiled into a book. God knows what happened. And so keep that in mind. So take this with a pinch of salt. And always, anytime your mind wanders, go where it takes you and have fun wandering. Don't say math is for some tangible benefit. Don't limit math to some utilitarian ideas. Right? Wonderful. All the best.